If you're watching this video, you'll be ready to learn basic calculus. First of all, excellent work. It's not easy to learn algebra and geometry just to make it this far. And we're here to help you. Before we get down to business, let's start first. What is two-sided limits?
The limit of f of x as x approaches a equals to f. A function f of x is to be continuous at x is equal to a if the limits of f of x as x approaches a is equal to f of a. Also, a function is said to be continuous on the interval a and b if it continues at each point in the interval. This definition is also implicitly assuming that both f of a and limit of f of x as x approaches a exists. If either of these does not exist, the function will not be continuous at x is equal to a.
Limit of f of x as x approaches to a equals L. If it satisfied both sides, the limit of f of x as x approaches to a from the right and limit of f of x as x approaches to a from the left are equal, we can say that two-sided limits exist.
Here are some examples.
Example number 1. Limit of 3x squared minus 5x plus 2 as x approaches to 2. First, make a t-table from the right and from the left. From the right, we can see here that as our x from the right get closer and closer to 2, our f of x or y get closer and closer to 4. From the left, we can see here that as our x from the left get closer and closer to 2, our f of x or y get closer and closer to the value of 4. Which means our f of x from the left is equal to the f of x from the right.
Graph the equation.
We are going to plot into the 2 of x and 4 of y, or f of x. As we can see in the graph that as x from the left and from the right get closer and closer to 2, our f of x or y from the left and right get closer and closer to 4, meaning to say our two-sided limit.
Using direct substitution.
Here is the sum example. We will just substitute the value of x to the equation. After we substitute, it will become
3x squared minus 5x plus 2.
3 times 2 raised to 2 minus 5 times 2 plus 2 equal 12 minus 10 plus 2 equal 4. So f of x is equal to 4.
Example number 2. Find the given limits in the graph.
Number 1. Limit of f of x as x approaches to negative 5. We can see here that as x get closer and closer to negative 5, our f of x get closer and closer to 4.
Number 2. Limit of f of x as x approaches to 0. We can see that the left and right limits are different because limit of f of x as x approaches to 0 from the left is equal to negative 1, and limit of f of x approaches 0 from the right is equal to 6, which means they are not equal, so two-side limit does not exist.
Number 3. Limit of f of x as x approaches to 2. We can clearly see that as x from the left and right get closer and closer to 2, our f of x from the left and right get closer and closer to 2.
Using direct substitution. Example number 3. Limit of f of x as x approaches to 1 equals 4x squared plus 5 over 3x. Just simply substitute the value of x. It will become 4 times 1 raised to 2 plus 5 over 3 times 1. equals 4 plus 5 over 3. Then it will become 9 over 3 equals 3. So 3 is f of x.
Direct substitution with a absolute value equation. Limit of f of x as x approaches to 7 equal 2x minus absolute value of x minus 7. If we encounter this equation, we will get first the absolute value of it. So the absolute value of it are limit of f of x as x approaches to 7 from the left equals 2x minus negative x minus 7, and limit of f of x as x approaches from the right equal 2x minus positive x minus 7. After we get the absolute value, substitute the value of x. From the left, just substitute the value of x and it will become 2 times 7 minus negative 7 minus 7 equal 14 plus 0 equal 14. From the right, substitute the value of x and it will become 2 times 7 minus 7 minus 7 equal 14 minus 0 equal 14. It means our limit of f of x as x approaches 7 from the left and limit of f of x as x approaches to 7 from the right are both equal to 14.
That's all. Thank you for watching. Please like and heart this video and also share it.